Okay, I'm going to try this example number 7 again. Didn't like how it was working out for any of my classes, actually. All right, first thing I did based on a student's suggestion was go ahead and add those two equations together, because what that does is it creates a third equation. So, not really add, I'm talking about eliminate a variable. So, for instance, I will multiply the top by a negative 3, and that forces, you'll see it here, negative 3x minus 6y minus 3z will now equal to a negative 12. And the bottom equation stays the same, and you'll notice that the y's are opposite of each other. So when I add straight down, I've eliminated the x's. So that goes away, and that leaves me with a negative 7y minus 7z equals to a, what was that, negative 21. Each of those has a multiple of 7. So to simplify that equation, I turn that into, divide each by a negative 7. So that gives me a y plus a z, and negative 21 divided by 7 is a 3. The reason I did that now, that's a third equation. I have 1, 2, 1, 2, 3 equations. So I take this third equation, solve it for either y or z, it doesn't matter. Since z's at the end here, I'll just go say z now is equal to 3 minus y. So what I'm going to do is take that z, and I'm going to plug it into the z here, plug it into the z here, because what does that do? It basically eliminates the z, and all I have is x and y's in two equations, which is supposed to be simpler to solve. So with the original equation, not counting, I'm not using the negative 3, I'm just going to go x plus 2y plus, instead of z, I'm going to write 3 minus y plus 3 minus y equals to a 4. The bottom equation, 3x's minus a y minus 4 times 3 minus y now equals to a negative 9. So there's my two equations, which is x's and y's. So it'll take a couple seconds. I got to distribute this negative 4, and I need to probably combine the two y's and move the 3 over in that one. So that looks like x, 2y minus a y is just a y, and then the 4 minus a 3 equals to a 1. The bottom equation, that becomes a negative 12, and that becomes a plus 4y. So the plus 4y has to be added to the negative y, and the negative 12 has to go to this side. So let's see, 3x's, negative y plus 4y is a 3y. Negative 9 plus 12 is a 3. So hopefully my equation is correct. So in order to eliminate one of those variables, I will probably multiply the top by a negative 3 and see what happens. And I think I got this before, this answer. I just didn't know what the PowerPoint or the notes was wanting it to be. I was expecting it to give me an answer. But if you recall, I said if you only have two equations and three unknowns, you're not guaranteed a solution. And I think this is the problem. It's a negative 3x minus 3y goes to a negative 3. Then I keep my 3x, my 3y equals to 3. And that cancels out, This is the problem. I was left with 0 equals to 0. That's a true statement. And see, I got that before, and I just wasn't thinking it could be right. Remember, this is example 7. Go ahead and check out what the PowerPoint says. But since I got this answer, and another student got the same answer as me, what this means is infinitely many solutions. That's what it meant. Okay? You just have to live with it. And that's where I'm going to leave it as.